This is about solving logarithmic equations and inequalities. So there are two techniques that work for most logarithmic equations and inequalities. So let's start with technique one, or what I will call technique one. I call this one reformatting. And let's do a couple of examples of this. Let's take log base 8 of x equals 4 over 3. Okay. What happens here is that the definition of logarithms is that this base raised to that power will give this number, whatever it is. Which means we can change it that way, reformat it, make it an exponential equation instead of a logarithmic. So we leave the x on this side, make it equal to bringing the 8 over here and making the number that's on the right become the exponent. And then we have to work with this. So let's think of that in a couple of ways. You can take the 3 and do the cube root of 8, which is one possible way. Remember that the denominator here means the root. So I could do the cube root of 8 and then that to the 4th power, which would be 2 to the 4th power. I can also do it where I take the 8 and I make the 8 as 2 to the 3rd power and 4 to the 3rd power. And since that's 3 over 1, we have 3 over 1 and 4 over 3. Rules of exponents are you multiply these, which is still 2 to the 4th power, which means x equals 2 to the 4th power, which is equal to 16. So in this case, this is 16. 8 raised to the power of 4 over 3 is 16. Now let's look at this example. Log base 6 x greater than 3. Now let's look at the inequality. Where the x is in relationship to the inequality sign, it must stay there. Don't flip it around. So back up here, I left the x on this side. It was immaterial when it was equal. I could have flipped it. I could have had the x over here and done 8 to the 4/3 over here. But I can't do that here. Unless, of course, I keep the greater than towards the x. So what you want to do is you want to keep the x here and keep the greater than part with the x. Don't put the x over here. You bring the 6 over here. Let's make that a little clearer as a 6. 6 to the 3rd power. So it says x is greater than 6 to the 3rd power, which is 216. So x is greater than 216. If you had done 6 to the 3rd power on this side and put the x over here, you would have had x is less than, because it would have been flipped. And that would have been incorrect for this problem. So keep it in this order. Keep the x in the order it starts at. Something like that. However you might want to say it to remind yourself that you don't flip it, you don't move the variable in. Now, this is a greater than problem. The variable, the x is greater than 216. We need to look at the one where it's less than, a different one. Let's do the same thing. Log base 6 x less than 3. Let's do it this way. When we do it this way, we get x is less than, we already know it's 6 to the 3rd power, so we'll be to 216. But now there's a different thing to be aware of. When you do logarithms, you cannot do logarithms of negative numbers. This x has to be a positive number. So what we have to do here is we have to account for the fact that when it says x is less than 216, that it doesn't go past 0. So we have to do something else. We have to add 0 is less than x, which is less than 216. We have to add that part. Okay. Because the best way to put it for now. Or rather, instead of x, I should say the logarithm must be positive. Or the logarithm, the x itself. Whatever this is. If this were x plus 5, then we could do it differently. But really, it's that the thing that's in there has to be positive. We'll get to some of those other ones later. So what you can see here is you use this reformat idea, making an exponential equation or an exponential inequality. But when it's a less than, you have to pay attention to the fact that it can't be negative. It has to be positive. All right, now let's look at the second technique. This is still 6-2. And I'll call it part 2. And technique 2, I call it delete, or deleting. What is delete? Deleting something. Look at this example. A, log base 4 x squared equals log base 4 negative 6x minus 8. So what we'll do now is notice something about that this is the same here. It's an equal. That means that this side and this side are exactly equal, and these two things are exactly equal. If those two things are exactly equal, then the ones I haven't covered up are also equal to each other. And that would be very easy to solve. So you're really not deleting log base 4 on the two sides. What you're doing is taking into account the concept that because both sides are equal and these two parts are equal, then the other two parts have to be equal to each other. So we can use that knowledge to set up this kind of equation, and now we can solve it. So this is x squared here, we've got those, let's bring those over to this side, add 6x to both sides, and add 8 to both sides. That means we're going to get 0 over here, and we're going to get x squared plus 6x plus 8. This is when factoring is so nice, when you're good at factoring. You can see that two numbers that multiply to 8 and add to 6 are going to be 4 and 2, and they both have to be positive. There's no coefficient for the x squared, or it's just 1, which allows you to set up this basic factoring. And because they're equal to 0, you can now have them separately. X equals a negative 4 here, x equals a negative 2. Separate them, do them. And so now it looks like we have a solution set of two numbers, but we need to check back up here and make sure that neither of these will give us a negative answer. So if I go back up here and I do log base 4 x squared equals log base 4 negative 6x minus 8. If I put negative 4 in here and square it, I get 16. I'm good. If I put negative 2 in here, negative 2 squared, that's going to be a 4. But now we need to put them over here. So negative 6 times negative 4 minus 8, that's 24 minus 8. So it looks like we're at 16, that's positive, we're good, and it's 16 and 16. And then if I do it with the negative 2, well, negative 6 times negative 2 minus 8, looks like that's positive 12, and 12 minus 8 is indeed 4. So we got 4 and we got 4 for the negative 2. Both of them are correct. Yay, that means that the solution set is negative 4 and negative 2. All right. Now let's do another one of these. This was 2a, but let's do 2b because, of course, we need to do it with an inequality. 2b, and this is still section 6.2. So we're going to do it with log base 3, 7x minus 6. Oops, I almost put plus. That's 7x minus 6 is less than log base 3, 4x plus 9. The idea of deleting these, or rather, because these two are equal, then these two have to be equal. Well, except it's not equals. But what it does say is that because this one is less than that one, that also has to be less than that one. So we can set it up that way, except that we really don't need to. What we're really doing here is we're going to test, or we're going to see, well, no, I guess we should do it just that way. Let's not do it differently. Let's just keep that there and use it. So because these two are true, less than the other, then this one has to be less than that. So let's do 7x minus 6 is less than 4x plus 9. And let's get the x's together. And that means I can get the other ones together. So I'm going to get 3x, nothing there, and 15. And I can divide by 3 here, and I get x is less than 5. Now, what's nice here is that this was not a negative. If I had divided by a negative 3, I would have had to switch the inequality sign, and I don't have to. Adding or subtracting, well, subtracting doesn't switch the inequality sign, only multiplying or dividing. And I did not divide by negative, so I'm good to go. Problem is that there are two other things to look at. There's a restriction here and a restriction here. And we have to account for those restrictions because they might change this. Right now it says x is less than 5. Because it's logarithms, that means we have, say, it can't go past 0. We don't need to add that yet because we first have to take into account that these two cannot be negatives. So what we have to do is separately do a 7x minus 6 must be greater than 0. And we will do a 4x plus 9 must be greater than 0. So we have an answer here, but we need to do these to account for those things. So let's add 6 to both sides. 7x is greater than 6. And then when I divide by 7, I get x is greater than 6 over 7, a little less than 1. Here I do minus 9, 4x is greater than negative 9. Divide by 4, x is greater than negative 9 over 4. But negative 9 over 4, this is when a mixed number will be nice because we're going to be graphing this in a moment. 4 goes into 9 twice with 1/4 left over, so that's actually negative 2.25 or negative 2 1/4. Now what we have to do is actually see what this looks like on a number line to see when we put all these together what's actually true. So I'm going to go like this, and I see I have a negative 2 1/4, so I want to go down farther here, and I want to go to a 0 to, let's say, negative 3, and here's negative 2. And here's negative 1, and here's 0, and here's 1, and here's 2. Oops, I'm not going to get all the way up to 5. Somewhere up here is 5. So at 5, it's not filled in all the way. It's an open circle because these are less than, not an equal to. At 5 on down, I'm going to do this with the graph because that symbol here is what tells you that there's numbers in between the 2 and the 5. So if that one's going this way, whoops, that one has to stop here. And then over here now, this is greater than negative 2 1/4. And this one's greater than 6/7, which is a little less than 1. Let's say 6/7 here. In order to get the answer to this, you have to account for the 3 of these and find the area where all 3 are together. Well, this area here they're not because 6 over 7 is greater than that and the 5 can't go below 0. And then over here, this area, well actually this area, no, 0 can't count. This area here, 5 less than 5, greater than 6 over 7, greater than negative 2 1/4. So this area here is all good. So 6 over 7 and 5 are our boundaries. The x's that make this correct, the x's that you're allowed to use based on these 3 results, fit in this area, and that means that these x's are greater than 6 over 7 and less than 5. That would be your answer. I'll just put brackets right around that. So when you do an inequality, you have to account for this if there are restrictions on it. See, on that one we did in the other one, let's go back to that one. This one here, we did the same restriction by saying it couldn't be negative. That was the only thing we had to worry about. This x has to be greater than 0. I guess I could have written up that since x is less than 216, let's also separately say that x here must be greater than 0, which is what we did. We then put those two together. But writing that down and thinking about it is in keeping over here with also taking this one and making it greater than 0, and taking this one and making it greater than 0. That gives us these boundaries. We show those on the number line, and then we do this one and show on the number line, and we find this area that is true. And therefore, here's our answer. All right. Now, I'm going to give you a couple of practice problems to do. And I want you to take a couple of minutes to do these, and then I will come back to the video, and you can then see it. Let me find these problems that I wrote. There it is. So, practice. First, log base 2x equals negative 2. Please do that one. And then second, I have enough room there to write it. I don't think I do. So I think I'm going to write it underneath, and then I'll just use the space later to do all the work. The second one would be log base 4, 6x minus 3 is less than log base 4, x plus 2. All right, go ahead and do that for a couple of moments yourself. In 5 seconds, I will begin going. So pause the video, do all the work, come back, and then you can watch me do that. All right, now I'm going to start doing these. Hopefully you did take the time to try to do them yourself to see if you could. So I'm going to start with log base 2x equals negative 2. I'm going to do the moving the 2 over here, do the reformat 2 to the negative 2. X, the negative is not really a negative, it's that math symbol telling you to bring 2 squared, or bring this to the bottom or the other part of the fraction and change that sign. And of course there has to be something up there, so the unseen 1, that's 1 times the 2, stays there. Because there's a 1 in front of everything, so we'll leave it there, and it's positive. And that's positive 1 exponent. And then we can write that as 1/4. So x equals 1/4 is your answer. Now the second one, write 1 there, now 2. Log base 4, 6x minus 3, less than log base 4, x plus 2. So let's identify here that for this one, 6x minus 3, it has to be greater than 0. Add 3 to both sides, 6x, I'll do a plus 3 just to be sure I get my signs right. Divide by 6, and x is greater than 1/2. Over here, x plus 2 must be greater than 0, so x must be greater than negative 2. So it's possible that we could have a negative for the x, because if the x is negative, then that would make these correct, if it also fits with the solution that we get. Now we can do the other part where we just, because these two are equal, or because this one is less than that one, this one is therefore less than that one. Less than x plus 2. So I'll subtract x on both sides. I'll also add 3 to both sides. So here we get 5x less than 5. X is less than 1. So let's see what we get. We have negative 2, negative 1, 0, 1, 2, and so on. Less than 1 is going that way. Greater than 1/2 is going this way. Greater than negative 2 is going that way. Well, it looks like because the 1/2 is going that way, we are pretty much stuck with just this area here. So that means 1/2 and 1, and x is in between them. So x is less than the 1 and greater than the 1/2. So let me write it over here where it's easier to see. 1/2 is less than x, which is less than 1. And that that is my solution set. Any of the numbers between 1/2 and 1 will make this a true statement. But if you go below that, you're getting either negatives or you're getting numbers that don't make it true, where it's not less than. Or greater than 1, you're going to have numbers that are not making it true. Okay, so let's see, if I put 0 in there, for instance, I would get a negative here, so that's no good. 0 would work here, but not over there. If I put, let's see, 5 in here, that's greater than 1, this would be 35. 5 times 6 is 30, 30 minus 3 is 27. But 5 plus 2 is 7. And those aren't equal anymore, so we can't do it. So this would be your solution set for that. Here's the solution for that one. And those are the main things I wanted to focus on here for section 6.2. So let's take a look again at the reformatting idea, okay, and then the deleting idea, how to delete them. And that's really simple, obviously, really easy to do. You just have to remember to do it, and you have to remember that if it's an inequality, that you have to check the regions there and actually pay attention to then what the greater than and less than's tell you, and base your solution on that. If you do that, you're going to go do quite well with these kinds of problems. So hopefully that helps. Please see me at Math Help if you have any questions about these. Thank you very much.